Section 1.2 Scientific Method Thinking like a Scientist. When you were very young, you explored the world around you by touching and tasting. As you grew, you asked questions about the world in which you live. What is lightning? Where does a rainbow come from? Why is water blue? As an adult, you may have wondered how antibiotics work or why vitamins are important to your health. Every day you ask questions and seek answers to organize and make sense of the world around you. When the late Nobel laureate Linus Pauling described his student of life in Oregon, he recalled that he read many books on chemistry, mineralogy, and physics. I mulled over the properties of materials. Why are some substances colored and others not? Why are some minerals and inorganic compounds hard and others soft? He said, I was building up a tremendous background of empirical knowledge and at the same time asking a great number of questions. Linus Pauling won 2 Nobel Prizes. The first in 1954 was in chemistry for his work on the nature of chemical bonds and the determination of the structures of complex substances. The second in 1962 was the Peace Prize. Scientific method. Although the process of trying to understand nature is unique to each scientist, a set of general principles called scientific method helps to describe how a scientist thinks. 1. Observations. The first step in the scientific method is to observe, describe, and measure an event in nature. Observation based on measurements are called data. Number 2, hypotheses. After sufficient data is collected, a hypothesis is proposed, which states a possible interpretation of the observations. The hypothesis must be stated in a way that can be tested by experiments. Number 3, experiments. Experiments are tests that determine the validity of the hypothesis. Often, many experiments are performed to test a hypothesis, and a large amount of information is collected. Many experiments are needed to support the original hypothesis. However, if one experiment produces a different result than predicted by the hypothesis, a modified hypothesis must be proposed. Then new experiments are conducted to test the new hypothesis. Number 4, theory. When experiments are repeated by many scientists with consistent results, the hypothesis may be confirmed. Consequently, that hypothesis may become a theory. Even then, a theory continues to be tested and, based on new experimental results, needs to be modified or replaced. Then the cycle of scientific method begins again with the proposal of a new hypothesis. Using the scientific method in everyday life. You may be surprised to realize that you use the scientific method in your everyday life. Suppose you visit a friend in her home. Soon after you arrive, the eyes start to itch and you begin to sneeze. Then you observe that your friend has a new cat. Perhaps you ask yourself why you are sneezing and you form the hypothesis that you are allergic to cats. To test your hypothesis, you leave your friend's house. If the sneezing stops, perhaps your hypothesis is correct. You test your hypothesis further by visiting another friend who also has a cat. If you start to sneeze again, your experimental results support your hypothesis that you're allergic to cats. However, if you continue sneezing after you leave your friend's home, your hypothesis is not supported. Now you need to form a new hypothesis, which could be that you have a cold.